Hello everyone. In this video, we are going to discuss about molecular mass and formula mass from the chapter 1 class 11 chemistry, some concepts of chemistry. So let us see first about molecular mass. You see, molecular mass, it is actually the sum of atomic masses of the elements present in a molecule. And you see, molecular mass is obtained by multiplying the atomic mass of each element by the number of its atoms and adding them together. See, let us see how to calculate the molecular mass of a compound. So for that, let us consider the example of methane. Its formula is CH4, 1 carbon atom and 4 hydrogen atoms. So we are considering one example of methane, and let us see how to calculate the molecular mass of methane. See, in this methane, there are 1 carbon atom and 4 hydrogen atoms. So you see, molecular mass, it is actually the sum of atomic masses of the elements present in a molecule. That is, to get the molecular mass of CH4, that is methane, it is actually obtained by multiplying the atomic mass of each element by the number of its atoms, then add them together. That is, when we consider the CH4 methane, there is 1 carbon atom and 4 hydrogen atoms. So we want to add the atomic mass of 1 carbon atom with the atomic mass of 4 hydrogen atoms. That together will give you the molecular mass of methane. So you see, the atomic mass of 1 carbon atom, that is 12.011 U. Okay, an atomic mass of 4 hydrogen atoms. You see, atomic mass of 1 hydrogen atom is 1.008 U. There are 4 hydrogen atoms. That is why we are saying that multiply the atomic mass of each element by the number of its atoms. So, atomic mass of hydrogen is 1.008 U. Now, the number of hydrogen atoms 4. So, we are multiplying them. Okay, now add these two. That will give you the molecular mass of CH4. So, when you add these two, you will get 16.043. So, this much U, that is actually U means unified mass. Now, let us consider the example of water molecule, that is H2O molecule. You see, in H2O, there are 2 hydrogen atoms and 1 oxygen atom. Then how can we find out the molecular mass of water? To get the molecular mass, you see, molecular mass is a sum of atomic masses of the elements present in a molecule. So, atomic mass of 2 hydrogen atoms plus atomic mass of 1 oxygen atom, that will give you the molecular mass of water. Okay, so this is actually equal to, there are 2 hydrogen atoms. Atomic mass of 1 hydrogen atom is 1.008 U. 2 hydrogen atoms, so into 2, plus atomic mass of 1 oxygen atom, so its atomic mass is 16 U. Okay, when you add these two, you will get 18.02 U. So you see 18.02 U, that is the molecular mass of water. Now, let us see how to solve this question number problem 1.1, which is given in your chemistry textbook. That is, you want to find out the molecular mass of glucose. You see, glucose molecule, its formula is C6H12O6. That is, in glucose, you see, there are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms. So to get the molecular mass of glucose, what you want to do? You want to add the atomic mass of 6 carbon atoms with the atomic mass of 12 hydrogen atoms with the atomic mass of 6 oxygen atoms. That is, the atomic mass of 1 carbon atom is 12.011 U. There are 6 carbon atoms, so into 6. Okay, plus atomic mass of 1 hydrogen atom is 1.008 U. There are 12 hydrogen atoms, so into 12. Plus atomic mass of 1 oxygen atom is 16 U. There are 6 oxygen atoms, so into 6. Okay, so when you multiply these two, that is 12.011 U into 6, you will get 72.066 U. Plus this will give you 12.096 U. Plus this will give you 96 U. Now, when you add these, you will get almost 180.162 U. So you see 180.162 unified mass U, that is the molecular mass of glucose. That is, you see, molecular mass is a sum of atomic masses of the elements present in a molecule. Okay, so I hope the idea of how to find out the molecular mass clear to you. Alright, you just want to find the atomic mass of each, element. There will be so many number of atoms present in it, so you just want to multiply that the atomic mass of one element with its number of atoms, then add all those together, you will get the total molecular mass of that molecule. Now let us see what is a formula mass. You see, formula mass is used for those compounds whose constituents are ions. That is, for example, sodium chloride. You see, in sodium chloride NaCl, the constituents are Na plus ion and Cl minus ion. So, formula mass is used for those compounds whose constituents are ions. So, if we consider the compound sodium chloride, actually we will be finding out the formula mass, not the molecular mass. Because you see, in sodium chloride, its constituents are not the molecules or atoms, they are ions, Na plus ion and Cl minus ion. That is, there are some substances such as sodium chloride which do not contain discrete molecules as their constituents unit. Their constituents will be ions like this. In such compounds, that is, in such ionic compounds, positive and negative entities, that is positive and negative ions, are arranged in a three-dimensional structure. You see, in sodium chloride, one Na plus ion will be surrounded by 6 Cl minus ions and one Cl minus ion will be surrounded by 6 Na plus ions. In a compound where the constituents are molecules or atoms, we use molar mass. But when the constituents are ions, we use formula mass. That is, in sodium chloride, it is an ionic compound, so we will be finding out the formula mass, not the molecular mass. You see, in sodium chloride, one Na plus ion is surrounded by 6 Cl minus ions and one Cl minus ion is surrounded by 6 Na plus ions. So here its ratio will be what? 6:6, that is equal to 1:1. That is, when we consider sodium chloride, it is not just like it has only one sodium or one chlorine. It is not so. There will be so many sodium and there will be so many chlorine. But see the ratio, it is 1:1. So, we just want to add the atomic mass of one sodium atom with the atomic mass of one chlorine to get the formula mass of sodium chloride. That is, we get the formula mass from the formula. Okay, we get the formula mass from the formula. So, formula mass is actually given by the sum of atomic masses of all the ions in the formula unit of an ionic compound. We just want to focus on the formula only. In the formula of sodium chloride, only one sodium is there and one chlorine is there. So we just want to add the atomic mass of one sodium with the atomic mass of one chlorine to get the formula mass of sodium chloride. So the sum of atomic masses of all the ions in the formula unit of an ionic compound will give you the formula mass of that ionic compound. Now, let us see how to find out the formula mass of sodium chloride. You see, in sodium chloride, we have one sodium and one chlorine. Okay, so the formula mass of sodium chloride will be equal to atomic mass of one sodium plus atomic mass of one chlorine. You see, atomic mass of one sodium, that is 23U, plus atomic mass of one chlorine is 35.5U. When you add these two, you will get 58.5U. So this is the formula mass of sodium chloride. That is, we just want to focus only on the formula. There is only one sodium atom, there is only one chlorine atom. So add the atomic masses of one sodium atom and one chlorine atom. That will give you the formula mass of sodium chloride. Now, let us see how to find out the formula mass of calcium chloride, CaCl2. So, you see in the formula of calcium chloride, there is one calcium and there are two chlorine. Okay, so you see calcium chloride, it is an ionic compound. That is why we are finding out the formula mass. Why? Because calcium chloride, no, actually it is Ca2 plus ion and Cl2 minus ions, no. Okay, so this is actually an ionic compound. That is why we are finding out the formula mass. Then there is only one calcium atom and calcium and there are two chlorine. Okay, ions actually. So the formula mass of CaCl2 will be atomic mass of 1 calcium plus atomic mass of 2 chlorine. So atomic mass of 1 calcium, that is 40. Okay, 40U plus atomic mass of 2 chlorine, that is 2 into atomic mass of chlorine. That is atomic mass of 1 chlorine is 35.5U. So atomic mass of 2 chlorine will be 2 into 35.5U. When you add these two, you will get 40 plus 71, which is actually equal to 111U. So this is the atomic mass of CaCl2. Now let us see how to find out the formula mass of ammonium nitrate, that is NH4NO3. You see in the formula there are two nitrogen, okay, one N here, one N here, so there are two nitrogen, 4 hydrogen, 3 oxygen. So the formula mass of ammonium nitrate will be equal to 2 into atomic mass of nitrogen, because there are 2 nitrogen in it, so 2 into atomic mass of nitrogen plus 4 into atomic mass of hydrogen plus 3 into atomic mass of oxygen. You see, so this will be equal to 2 into atomic mass of nitrogen is almost 14.007U. Okay, plus 4 into atomic mass of hydrogen, which is 1.008U. Okay, plus 3 into atomic mass of oxygen, which is 16U. Okay, so when you add these, 2 into 14.007U will be 28.014U plus 4 into 1.008, that will be almost 4.0320 plus 16 into 3, 48U. Okay, when you add all these, you will get it as 80.046U, or this can be approximately written as 80.05U. So you see, this is the formula mass of ammonium nitrate. So in this video, we have discussed about the molecular mass and formula mass. You see, molecular mass is obtained, it is actually the sum of atomic masses of the elements present in a molecule. Okay, formula mass is actually used for ionic compounds, and formula mass is actually the sum of atomic masses of all the ions in the formula unit of an ionic compound. So I hope the idea of molecular mass and formula mass clear to you. Thank you.